This documentary doesn't aim to overwhelm you with effects or simulations. You won't see water gushing in slow motion through animated pipes. What you'll get instead is something rarer, a deeply researched, long-form story about one of the most brilliant engineering systems in the history of civilization. We take clean water for granted today, but in the ancient world, water meant survival. For the Romans, it also meant control. The aqueducts they built weren't just public works, they were statements of power, discipline, and foresight. They carried not just water, but identity. Where Roman aqueducts reached, Roman order followed. This story is about more than channels and arches. It's about vision, about how an ancient people solved problems that modern cities still struggle with, and about how, 2,000 years later, many of their solutions still stand, not just in stone, but in relevance. Welcome to History's Edge. This is the story of the Roman aqueduct. Chapter 1. A thirsty city. In the beginning, Rome had no aqueducts. The city that would one day rule a continent started, like so many others, beside a river. The Tiber flowed muddy and slow past its early huts and temples, carrying silt, sewage, and disease. It was water, but it wasn't clean. It wasn't controlled. And as Rome grew, the Tiber alone couldn't keep up. By the late 4th century BCE, the city was crowded. Its population had expanded far beyond its original settlements on the Palatine and Capitoline hills. Wells dug into the ground provided some relief, but groundwater was unpredictable and often polluted. Rainwater was collected in cisterns, but it wasn't enough. For the public baths, the fountains, the markets, and the growing thirst of tens of thousands of people, Rome needed something more. And so, around 312 BCE, under the censor Appius Claudius Caecus, Rome built its first aqueduct, the Aqua Appia. It wasn't glamorous. It ran mostly underground, following a steady slope for over 16 kilometers. But it worked. It delivered fresh water into the city from springs east of Rome, reliably, silently, and without pumps. This was a revolution. For the first time, Rome was no longer tied to the water immediately beneath or beside it. It could reach for better water, cleaner, colder, more plentiful, and bring it home. Not by magic, but by math, by surveying, by gradient, by stone. The concept wasn't entirely Roman. Aqueduct-like systems had existed in Persia, in Greece, and in Egypt. But what Rome did was different in scale, in precision, and in permanence. They didn't just build for utility, they built to last. They built with the confidence that their city would still be there centuries later, and that its water would still flow. The Aqua Appia set the pattern. Water brought from distant springs via gently sloping channels, moving purely by gravity. The channel, called the specus, was typically enclosed in stone or concrete, sealed with waterproof mortar and buried to protect it from contamination and damage. Where valleys intervened, it was elevated on arcades. Where hills blocked the way, it was tunneled straight through. This engineering discipline became part of Roman identity. By the 1st century CE, Rome had not one aqueduct but 11. Together, they brought in over 300 million gallons of water per day, more than many modern cities use even now. The water wasn't just for drinking. It flowed into public baths, ornamental fountains, latrines, and private homes. It flushed sewers and cooled villas. It became the bloodstream of the city, always moving, always available. And this abundance had a political dimension. Roman emperors used water to build legitimacy. Augustus, Trajan, and others restored, expanded, and named aqueducts to show their generosity. Providing water wasn't just a civic duty, it was a mark of power. But it all began with need. With a thirsty city crowding around wells and rain jars, hoping for a better solution. And Rome found one. It followed the land, listened to gravity, and carved a new future. One drop at a time. Chapter 2. How it worked. The Roman aqueduct wasn't a marvel because it was complicated. It was a marvel because it wasn't. The entire system was built on one simple principle: gravity. Water flowed downhill. That was it. No pumps, no pressurized pipes, no mechanical engines, just altitude, patience, and precision. But to make gravity work across dozens of kilometers, the Romans needed two things: good surveying and even better discipline. It started at the source. Romans preferred natural springs, clean, cool, and high in elevation. The water had to begin higher than the point where it would enter the city, because gravity would do all the work. From there, engineers mapped out a path that followed the land's natural contours. Not in a straight line, but in the line that worked. Sometimes that meant digging tunnels. Other times it meant building arcades to bridge low ground. Whatever it took to maintain a steady, gentle slope, usually just 0.5 to 1 meter of drop per kilometer. Surveyors used tools like the chorobates, a long wooden bench fitted with water levels to detect even the slightest tilt. With it, they could trace out routes accurate enough to keep water moving steadily over enormous distances. Mistakes were rare and costly. A slope that was too steep caused erosion and damage. Too shallow, and the water stopped. Once the path was mapped, construction began. The main water channel, called the spicus, was typically rectangular, lined with stone or brick, and sealed with waterproof mortar. Often buried underground, it stayed cool, safe from tampering, and protected from sunlight and contamination. In valleys, the spicus was raised on arches, not for beauty, but to maintain slope. In hills, it was cut into rock or tunneled through entirely. Roman tunnels could stretch for kilometers, dug from both ends and meeting almost perfectly in the middle. At intervals, the flow was controlled with settling tanks, which allowed sediment to drop out before the water continued. Air vents were sometimes built into longer tunnels to release pressure and prevent vacuum buildup. Where needed, the system included bridges, siphons, or even pressurized pipe segments made of lead or stone. But these were exceptions, not the rule. The genius of the aqueduct wasn't technical complexity, it was consistency. By the time water reached the city, it was directed into massive distribution tanks called castella. From there, it split into separate flows: public fountains, baths, latrines, and sometimes private homes. Each outlet was carefully regulated. Not all water was equal. Some aqueducts carried cleaner water for drinking. Others brought lower quality supply for baths or sewers. Allocation wasn't random, it was strategic. The system was also self-cleaning to a degree. Constant flow helped reduce stagnation and kept sediment from building up too quickly, but maintenance was still required. Workers regularly inspected the channels, cleared blockages, and repaired damage. These weren't passive structures. They were living parts of the city in constant use. And above all, they were durable. Many aqueducts used Roman concrete for foundations, vaults, and waterproof linings. That meant minimal leakage and long-term strength. The materials lasted centuries. In some places, they're still intact. All of this, slope, structure, sourcing, and regulation, was standardized across the empire. In Gaul, in Syria, in North Africa, Roman aqueducts followed the same design logic. Whether supplying a garrison town or a provincial capital, the system stayed the same. It was infrastructure as ideology, order imposed on nature, replicated at scale. What made Roman aqueducts extraordinary wasn't that they moved water. It's that they did it so simply, so consistently, and for so long. No electricity, no steel, just knowledge and gravity. And Chapter 3: Engineering the Flow. From a distance, Roman aqueducts might look like a series of arches marching across the landscape. But those arches were only the most visible part of something far more complex. a carefully calculated system designed to carry water over vast distances with almost no mechanical assistance. Behind every stretch of masonry was a network of planning, surveying, and mathematical precision that still impresses modern engineers. The key to Roman water transport was gradient. Water doesn't flow uphill, and the Romans, lacking pumps, relied entirely on gravity. That meant every aqueduct had to descend gradually, predictably, and continuously, from source to city. Too steep a slope, and the water would erode the channel. Too flat, and it would stagnate or stop. To achieve this balance, Roman engineers used simple but effective tools. The chorobates, a wooden levelling bench with a water channel, helped determine slope. The dioptra, a kind of ancient theodolite, measured horizontal angles. These tools allowed them to plot paths over tens of kilometres, sometimes over 80 kilometres or 50 miles, with elevation drops of just a few metres. Take the Aqua Marcia, one of Rome's longest aqueducts. It stretched over 91 kilometres, or about 57 miles, and dropped only 264 metres, around 866 feet, from source to terminus. That's a gradient of less than 0.3%, an astonishing feat, especially considering that most of the route was underground, and much of the measurement had to be done by hand. The result was a system where water moved at a gentle, steady pace. Flow speeds were usually between 1 to 3 kilometers per hour, roughly 0.6 to 2 miles per hour. Enough to deliver millions of litres daily, without pressure, bursts, or erosion. Most aqueducts followed the contours of the land. They curved around hills, ducked into tunnels, or were buried beneath fields. Only when necessary did the Romans raise the channel on arcades. And even then, the arches weren't just elegant. They were structurally efficient, made from opus caementitium, or Roman concrete, often faced with stone or brick to resist weathering. Underground stretches were the norm, not the exception. Tunnels were cut by teams working from both ends, often meeting in the middle with minimal error. Some were hundreds of meters long. In one famous example, the engineers of the Aqua Claudia drove tunnels through solid rock, using shafts spaced every 35 to 50 meters, about 115 to 165 feet, to remove debris and correct course. Where valleys interrupted the path, the Romans built arcades. Where hills blocked the route, they dug tunnels. And in rare cases, such as in Aspendos in modern Turkey, they used inverted siphons, a pressurized pipe system that dropped water into a low valley and forced it uphill again on the other side, using gravity and hydraulic pressure. Surveying wasn't limited to straight lines. Roman engineers had to account for terrain, climate, and soil conditions. In marshy areas, they drove piles into the ground and built platforms. In earthquake zones, they used flexible joints and thicker support piers. In colder provinces, they buried the channels deeper to avoid freezing. And it wasn't just about function. It was about longevity. The Romans didn't build aqueducts to last 10 or 20 years. They built them to endure, and some did. Many original channels are still visible, and some are still standing after nearly 2,000 years. All of this was achieved without steel, electricity, or digital models. Just rope, water, stone, and the kind of planning that took years of patience and a deep understanding of terrain. If Roman roads showed the empire's reach, aqueducts showed its control. They turned the unpredictable, weather, landscape, elevation, into something reliable, a daily flow, a guarantee. And that guarantee was built, literally, one slope at a time. Chapter 4. Baths, Fountains, and Flow. When water reached the edge of Rome, it didn't just trickle in. It arrived with intention. The aqueducts weren't built just to move water into the city. They were designed to distribute it with precision, purpose, and scale. Once inside the city limits, that stream of water was divided, redirected, stored, and then unleashed into a world that depended on it. At the heart of the distribution system were the castella, large holding tanks usually built of concrete and faced with stone. Think of them as Roman water junctions. Each aqueduct had one or more, often located on elevated ground. From here, water was split into separate pipelines. One branch might serve a public fountain, another a bath complex. Others ran into sewers, gardens, even private homes, if you were wealthy enough to pay for a connection. These castella were sometimes multi-chambered, with sedimentation features that allowed heavier particles to settle out. Inscriptions found on some tanks even list which aqueduct fed them and how the water was allocated, a level of bureaucratic control that still surprises modern engineers. And this is key. The Romans didn't just care about water supply, they cared about flow. A constant moving current kept the system clean, pressurized, and functioning. Water wasn't stored in large reservoirs like we do today. It was kept moving, always. The aqueducts ran day and night, their output shaping the rhythm of Roman life. One of the most visible expressions of this system was the public fountain, the Lacus. Dozens were scattered across Rome, from back alleys to central forums. They weren't ornamental, they were essential. This was where the average Roman collected water for cooking, drinking, and washing. The flow never stopped. You didn't turn a tap, you just filled your jug. These fountains were engineered for constant overflow. Once the basin filled, the excess spilled into channels that fed sewers, watered plants, or supplied lower basins. It was a cascading system, elegant, efficient, and waste-free. And then there were the baths, Rome's most social spaces. From the modest neighbourhood balneum to the monumental thermae of Caracalla, baths were temples of water. Heated pools, cold plungers, steam rooms, and open-air swimming spaces, all fed by aqueducts. The engineering here was layered. Water was often brought in at high pressure to serve large volumes. Hot rooms, called caldaria, used underfloor heating systems known as hypercausts, where hot air from wood-fired furnaces passed through raised floors and hollow walls. The water for hot baths wasn't just warmed, it was scalding. Heating took massive amounts of energy and constant flow. The aqueducts made it possible. Estimates suggest the baths of Caracalla alone used over 10 million litres of water per day. And yet, even as it served thousands, the water kept moving, draining into sewers, then back to the Tiber. The Romans didn't recycle in the modern sense. They simply used more water than almost any ancient civilization, and built the infrastructure to handle it. Wealthy Romans could request private connections, piped directly into their homes or gardens. These came at a cost and required special permits. The poet Martial joked about citizens boasting of their piped fountains while their neighbours still waited in line at the public basin. Social class was visible in plumbing. Even the latrines, Rome's public toilets, were powered by aqueduct water. Channels ran beneath the stone benches, washing away waste continuously. Some had sponges on sticks for cleaning, soaked in running water. It's not glamorous, but it was advanced, especially when compared to sanitation in much of Europe centuries later. And while most people focus on water coming in, the Romans paid equal attention to where it went. Beneath the city ran the Cloaca Maxima, the massive sewer first built under the kings, later expanded to handle runoff from fountains, baths, and latrines alike. Fed by excess aqueduct water, it helped keep the city cleaner than many urban centres of the Middle Ages. This flow, constant, calculated, and civic-minded, was the soul of Roman urban life. Water wasn't just a utility, It was an experience, a public good, a status symbol, and a force that literally moved through every part of the city, from the poorest alley to the emperor's palace. Aqueducts didn't just change what Romans built, they changed how Romans lived. Chapter 5. The Reach of Water. Rome was not the only city to taste the gift of running water. As the empire expanded, so did the aqueduct. It became more than a utility. It became a Roman signature, carved into hillsides and stretched across valleys far from the capital. Wherever the legions went, water followed, channeled through stone and concrete to the new cities of empire. In Gaul, Spain, North Africa, and the Near East, Roman engineers built aqueducts to supply veteran colonies, administrative centres, and trading hubs. These weren't crude copies of Roman infrastructure. They followed the same standards, used the same surveying tools, and delivered water with the same efficiency as the systems in Rome. Some of these aqueducts still survive today, more intact than those in the capital. The city of Segovia, in modern Spain, has one of the most famous examples. Built in the late 1st or early 2nd century CE, its arcade cuts directly through the heart of the city. The granite blocks were laid without mortar, locked so precisely that the structure has survived centuries of earthquakes, war, and weather. Its speaker still sits above the tallest arch, as if waiting for the water to return. In Tunis, ancient Carthage was supplied by an aqueduct nearly 130 kilometers long, drawing from the spring of Zakouan. The final approach was carried by a soaring arcade that can still be traced today, running across olive groves and low hills. It was an engineering link between Roman Africa and the traditions of the capital. In Antalya, Turkey, the aqueduct of Aspendos used a rare form of pressurized technology called an inverted siphon. Rather than a simple arcade, the water crossed the valley in U-shaped pipelines made of lead and stone, joined with lime mortar and sealed with bitumen. The entire structure relied on the force of gravity and internal pressure to push water uphill at the far side of the valley. It's an example of Roman adaptability, not just copying one model, but solving new problems with old principles. One reason Roman aqueducts spread so widely was that the technology itself was portable. The essential tools fit in a soldier's pack or an engineer's hand. The chorobates, the groma, the measuring rods and plumb lines. These weren't complicated machines. They were simple, reliable instruments that could be used anywhere in the empire. And they worked because Roman training was consistent. Engineers from Alexandria could collaborate with builders from Lyon and masons from Jerusalem, all using the same language of construction. But the reach of water was more than geographic. It was political. An aqueduct in a new province wasn't just a sign of progress. It was a mark of Roman control. It told local populations that Rome could bring order, discipline, and comfort. It was an arm of soft power. Water flowed, and so did culture. Towns with aqueducts often saw the rise of other Roman features: bathhouses, latrines, paved roads, and forums. In this way, aqueducts acted as arteries of Romanization. They were not just delivering water, they were delivering a way of life. Even when local elites funded aqueduct construction, as sometimes happened, the layout and structure followed Roman conventions. Inscriptions on the arcade piers often carried the names of governors, emperors, or city magistrates who paid for the project, making each stretch of stone both a civic service and a permanent advertisement of loyalty to Rome. And in some places, the infrastructure outlived the empire. In parts of France, aqueduct tunnels were converted into wine storage. In Syria and Jordan, sections of ancient aqueducts were reused for irrigation centuries after the legions had left. The engineering didn't die with the politics. It lingered in stone and function. This reach across space and time is one of the most remarkable things about the Roman aqueduct. It was not just built once and forgotten. It became part of the land it passed through, absorbed into daily life, repurposed again and again. The aqueduct was more than a structure. It was an idea, carried by gravity and held together by belief, that cities should have water, that people should bathe, and that order could be built from the mountains to the sea. Chapter 6: Water and Power. In ancient Rome, water was not just a necessity, it was a message. Flowing through arcades, fountains, and baths, water carried meaning. It wasn't simply about hydration or sanitation, it was about authority. Whoever controlled the water controlled the city. From the very beginning, aqueducts were closely tied to political power. The Aqua Appia, Rome's first, was built under a censor, an official responsible not only for infrastructure, but also for public morality and citizen conduct. Appius Claudius Caecus didn't just want to bring in water, he wanted to build reputation, and he did. The aqueduct bore his name, just like the famous road he built soon after. Water, like roads, was legacy. Later, emperors would take this to new levels. Augustus oversaw the repair of existing aqueducts and the creation of new ones. He appointed a trusted official, Marcus Agrippa, to manage the water supply. Agrippa wasn't just a general, he was a builder. In his year as a dial, a role often seen as a stepping stone to higher office, he reportedly repaired hundreds of fountains and dozens of castella, expanded aqueduct lines, and donated his own money to keep the flow running. His work was so respected that when Frontinus, a later water commissioner under Emperor Nerva, wrote his detailed treatise on Rome's water system, he still referred back to Agrippa as the benchmark of public service. That treatise, De Aquis Urbis Romae, is one of our richest sources today. In it, Frontinus lays out a meticulous inventory of aqueduct lengths, sources, flow rates, and regulations. But more than that, he makes clear that managing water meant managing Rome. He railed against illegal taps, corruption in distribution, and private citizens diverting flow without authorization. These weren't just plumbing problems, they were threats to order. Water was tightly regulated. Only citizens of a certain class could apply for a private connection. The rest used public fountains and baths. Even among the elite, the amount of water allocated could be a marker of favor. A senator, with a private supply feeding his garden pool, wasn't just enjoying luxury, he was signaling his status. And aqueducts weren't just about Rome. In the provinces, their construction was often tied to loyalty. Cities that built them, or had them built by the emperor, were seen as civilized, Romanized, loyal. A city with an aqueduct had made a leap. It had stepped out of the tribal past and into the order of empire. Some aqueducts bore long inscriptions chiseled into marble plaques at entry points, listing the name of the emperor or governor who paid for it. These weren't hidden credits. They were public announcements of power. The water flowed because someone in charge had made it happen, and that someone wanted to be remembered. Even the physical design of aqueducts served this political purpose. In Rome, the towering arches of the Aqua Claudia were visible from miles away. They didn't need to be that tall, but they were. Monumental. A visible line across the sky saying, "This city is ruled by order. This city is sustained by power." There were symbolic moments too. After Nero's fire in 64 CE, large portions of the city had to be rebuilt. One of the first priorities was restoring aqueducts. Without water, there could be no reconstruction, and so rebuilding the flow became a way to restore control. At the same time, water could be a political weapon. Cutting off an aqueduct was a known siege tactic. Roman engineers even knew how to sabotage enemy waterworks or defend their own with walls, diversions, and hidden segments. In times of peace, the threat wasn't from invaders, but from neglect. A dry fountain could spark unrest just as quickly as a bread shortage. Water was power, not because it was rare, but because it was essential, and Roman leaders knew it. They managed it, celebrated it, engraved their names on it, and sometimes used it to punish or reward. The aqueduct wasn't just a utility, it was a symbol. It told people that the empire worked, that the emperor provided, that Rome flowed clean and constant even as the world around it changed. Chapter 7. The Maintenance Machine. For all their elegance and scale, Roman aqueducts weren't self-sustaining. Water flowed by gravity, but the system didn't run on autopilot. It had to be maintained constantly. Keeping the water clean, the channels clear, and the structures standing required more than engineering. It required a system, and the Romans built one. By the early imperial period, aqueduct maintenance was formalized into a public service. The state employed teams of aquarii, workers tasked with inspecting, cleaning, and repairing the infrastructure. They weren't freelancers. They were on payroll, assigned to specific stretches of aqueduct. Their job descriptions were detailed, and their work was supervised by a central authority, the curator aquarum, or water commissioner. One of the most detailed accounts of this operation comes from Sextus Julius Frontinus, the same official who mapped out Rome's water supply under Emperor Nerva. His treatise, De Arcis Urbis Romae, reads like a combination of engineering manual and bureaucratic memo. He describes the problems his teams faced: blockages, illegal diversions, limescale buildup, and the systems they used to solve them. Limescale, for example, was a major challenge. Roman water, especially from limestone-rich regions, carried high mineral content. Over time, calcium carbonate would deposit along the walls of the specus, narrowing the channel and reducing flow. If left unchecked, the buildup could completely clog a section. Cleaning it meant scraping or chiseling the deposits off by hand, sometimes while standing knee-deep in cold water with only torchlight for visibility. To make access easier, engineers built inspection shafts, called puttae, spaced at intervals along underground sections. These vertical shafts were fitted with footholds or ladders, allowing workers to climb in, check for damage, and clear debris. In some tunnels, carved graffiti left by aqueduct crews survive to this day. Names, dates, and even crude jokes from the men who kept the water moving. But maintenance wasn't just about cleaning. It was also about defense. The system was vulnerable to tampering. Illegal taps, called punctures, were a constant issue. Wealthy landowners or bath operators sometimes diverted water without permission, carving holes into the aqueduct walls or tapping into underground sections. Frontinus catalogued these violations with visible frustration and passed laws to regulate them. The response was both legal and physical. Inspectors patrolled key routes. Offenders could be fined or ordered to remove illegal pipes. In some areas, aqueducts were enclosed in masonry or placed underground to make unauthorized access more difficult. Above ground, the arcades required a different kind of attention. Mortar cracks, weather damage, and shifting soil could destabilize piers and arches. Periodic surveys identified weak spots, and teams were dispatched to shore them up with fresh masonry. Inscriptions sometimes record these repairs, especially when done under imperial command. A small plaque reading "Restituta per Imperium," restored by order, marks a quiet victory of maintenance over collapse. Even seasonal change was considered. In winter, aqueducts in colder provinces had to be protected from freezing. Some channels were buried deeper to keep the flow above freezing point, while others used insulation layers like crushed brick and clay. The Romans knew that a frozen specus could crack and leak when it thawed, damaging the entire line. One of the most advanced maintenance decisions the Romans made was redundancy. Many cities had multiple aqueducts feeding from different sources. This wasn't extravagance, it was strategy. If one line was under repair or suffered contamination, another could keep the baths full and the fountains flowing. It's easy to admire Roman aqueducts for their design, but it's the maintenance that made them miraculous. Any civilization can build, fewer can sustain. The Romans didn't just construct a water system, they built a workforce, a rulebook, and a rhythm, and through that rhythm, their cities remained alive. Chapter 8. The Fall and the Silence. No system lasts forever, not even Rome's. For nearly 1,000 years, Roman aqueducts carried water to cities, forts, baths, and farms. Then, one by one, they fell silent. The channels dried up, the fountains stopped flowing, and what had once been the pulse of the empire faded into stone ruins and buried memory. The decline was not instant. There was no single moment when the water stopped. Instead, it came in waves. Wars, economic collapse, depopulation, and neglect. As the Western Roman Empire weakened in the 4th and 5th centuries, maintenance of the aqueducts became harder to fund, harder to organize, and harder to prioritize. When the Goths besieged Rome in 537 CE, their commander, Witiges, targeted the aqueducts. It wasn't a new tactic. Romans had done the same to others. But this time, the damage was lasting. Most of the aqueducts into the city were cut, and the Byzantine general Belisarius, defending Rome, couldn't fully repair them. From that moment on, the city would never again receive water at the volume it had under the emperors. And the city itself was changing. Rome's population collapsed, from perhaps over 1 million people in the 2nd century to fewer than 50,000 in the early Middle Ages. Whole districts were abandoned. The massive public baths were too expensive to operate. The grand fountains and latrines served no one. Aqueducts, without constant repair, cracked and crumbled. Nature reclaimed what had been managed. Weeds grew through stone joints. Animals nested in speakers' tunnels. Sediment filled the channels. In some cases, locals dismantled the aqueducts themselves, reusing the finely cut blocks for churches, walls, or villas. Still, not all was lost. Some aqueducts continued to function, at least in part. In Gaul, Asia Minor, and parts of North Africa, aqueduct-fed fountains and baths operated well into the early medieval period. In the Eastern Empire, where administration remained stronger, water systems survived longer. Constantinople had an imperial aqueduct, the Valens Aqueduct, that remained in use and was repaired as late as the 10th century. In some places, the memory of the aqueduct remained even when the water didn't. Farmers walked along the ruins, using them as boundary markers. Monasteries were built near spring sources once tapped by Rome. Occasionally, a curious traveller would describe the bridges that didn't seem to go anywhere. It wasn't until the Renaissance that scholars began to seriously study these ruins again. Some, like Leon Battista Alberti, saw in the aqueducts a model for new architecture. Others simply admired their scale. By the time of the Enlightenment, aqueducts had shifted from utility to symbol. They represented lost knowledge, ancient order, and forgotten capability. But behind the symbolism was a simple truth. The fall of the aqueducts meant the loss of health, hygiene, and public life. In post-Roman Europe, disease spread more easily in cities without running water. Baths were abandoned or condemned as immoral. Urban life shrank into clustered towns around wells, with no fountains, no sewers, and no sanitation system to replace what had once flowed freely. That change was not just technical, it was cultural. The very idea that water could be clean, public, and constant was forgotten, and in many places it would not return for over 1,000 years. This silence, more than any broken stone or ruined arcade, marks the end of the Roman aqueduct. Not just the loss of a structure, but the end of a relationship between a people and their water, between cities and their sources, between engineering and everyday life. What the Romans built wasn't just a network, it was a habit, and when that habit ended, something vital disappeared with it. Chapter 9: Rediscovery and Resurrection. For centuries, the aqueducts stood like skeletons, bridges without roads, arches without purpose, tunnels without water. They were familiar to locals and foreign travellers alike, yet their meaning had faded. People walked beneath them, marvelled at them, sometimes feared them, but few understood what they once were, or how they worked. Then, slowly, curiosity returned. In the 15th century, as Europe began to rediscover its classical past, Renaissance scholars turned their eyes to Rome's ruins. Among the shattered temples and fallen columns stood the aqueducts, weathered but still standing. Some were partially buried. Others were stripped of facing stones, but they had survived, stubbornly resisting time. Humanists like Leon Battista Alberti and Poggio Bracciolini walked among these ruins with notebooks in hand. They measured arches, sketched details, and compared the structures to what little they could read in ancient texts. Vitruvius's De Architectura, long forgotten in monasteries, was now being copied, translated, and studied. And with it came hints about how the Romans once moved water across landscapes. Interest wasn't just academic. The growing cities of early modern Europe needed better infrastructure. Rome, now the seat of the papacy, was again struggling with water shortages. Wells and cisterns weren't enough for a population that was starting to grow again. Public health depended on clean water. So, in the 16th century, engineers and papal officials decided to act. Pope Sixtus V commissioned the restoration of the Aqua Alexandrina, one of Rome's ancient aqueducts. Under the guidance of engineer Domenico Fontana, the ruined channels were surveyed, cleaned, and rebuilt. In 1587, water flowed again, not through every part of the original system, but enough to power new fountains and public supply points. It was renamed the Aqua Felice in honour of the Pope's birth name, Felice Peretti. This was more than a repair job. It was a rebirth. For the first time since antiquity, a Roman aqueduct had been revived for public use, and with it came renewed respect for Roman engineering. Engineers across Europe took note. In France, Sébastien Leprestre de Vauban, the military engineer of Louis XIV, studied Roman water systems while building fortresses and urban infrastructure. In England, John Smeaton, often called the first civil engineer, cited Roman aqueducts as models of endurance and gradient control. Meanwhile, Enlightenment scholars like Montesquieu and Edward Gibbon referenced aqueducts not only as feats of engineering, but as symbols of what was lost when empire gave way to decline. The aqueduct became a metaphor, not just a conduit, but a current of knowledge, interrupted and then resumed. By the 19th century, archaeology had become a formal discipline, and aqueducts were being excavated systematically. Researchers mapped their routes, studied inscriptions, and used modern tools to measure slopes that ancient surveyors had calculated by hand. The results were often humbling. In many cases, the Roman tolerances were more precise than expected. Gradients maintained over 40 or 50 kilometres, with a margin of error smaller than a modern city engineer might risk. Today, Roman aqueducts continue to inspire. In some parts of the world, their routes have been studied to inform modern water projects. In Nimes, Segovia, and Tunis, the remains are not just preserved but celebrated, woven into city identity. UNESCO has listed several as World Heritage Sites. not just for their beauty, but for what they reveal about design, purpose, and endurance. More than anything, the rediscovery of aqueducts has reminded us of something essential. Infrastructure is memory. It speaks of what a society valued, what it knew, and what it left behind. When Rome fell, its water fell with it. But when the water returned, centuries later, so did something else. A recognition that engineering, done right, can last longer than kings, nations, or empires. The aqueducts came back. Not in full, not everywhere, but enough to prove a point. That knowledge may sleep, but it doesn't always die. Chapter 10. What remains? Stand beneath a Roman aqueduct today, and you stand beneath time. You don't need to imagine the past. It's still there, in the curve of the arches, in the weathered blocks, in the quiet shadow of a structure that once pulsed with water. What remains is more than stone. It's a message. From Nimes to Rome, from Aspendos to Segovia, aqueducts still mark the land. Some are intact, some are fragments. Some lie half buried in fields or tucked behind modern apartment buildings. And yet, they are still part of the world. Not as ruins, but as reminders. They remind us of what civilization can do when it thinks ahead, when it builds not for the moment, but for generations. The aqueducts were not decoration. They were not temporary. They were designed to outlast their builders. In many places, they did. What's even more striking is how quietly they once operated. No pumps, no motors, just gravity, calculation, and care. The entire system worked in silence. Water arrived not in torrents but in a steady flow, moving without force, only design. In a world where infrastructure often feels fragile, disposable, or invisible, Roman aqueducts feel like the opposite. They are the bones of an order that valued function, durability, and public service. They remind us that engineering can be more than utility. It can be an expression of trust, a promise to the future. Even today, archaeologists are still discovering hidden aqueduct lines. New imaging techniques have revealed buried channels beneath fields and cities, places where the land once carried water and people have long since forgotten. The story isn't finished. It's still being uncovered. In some ways, we are only now catching up. Our own systems are more complex, more fragile, and less visible. We depend on electricity, pressurized pipes, and advanced materials. But we also depend on knowledge, and that's something the Romans shared. They left behind not just structures, but records. Frontinus's writings, Vitruvius's manuals, the inscriptions on stone. These are all part of the legacy. They show us how water was moved, how cities were planned, and how people thought about the connection between nature and order. And while aqueducts are often studied for their architecture, their real importance lies elsewhere, in what they enabled, in the way they let cities breathe, in the way they turned basic survival into public life, fountains in the street, baths in the neighborhood, gardens in the courtyard. The aqueducts carried water, but they also carried culture. What remains is more than stonework. It's a worldview, one that saw infrastructure not as background, but as foundation, one that knew clean water mattered just as much as laws, temples, or armies. That view eroded. The channels cracked, the water dried up, but the aqueducts are still here, waiting, watching, whispering what they once were, and what we might be if we choose to build that way again. From the archives of history's edge. This documentary took months of verifying and rewriting, because with history, detail matters. Every fact you've heard has been checked, cross-checked, and anchored in modern scholarship. It would have been easier to rush this, to dress it up with flashy visuals and let a script glide over the complexity. But we don't believe in shortcuts. We believe in getting it right, even if that means fewer views and slower growth. So if you've made it this far, thank you. You're not just part of our audience, you're part of a small but steady movement of people who still value long-form truth over short-form noise. If you'd like to help this work continue, please consider subscribing, sharing, or just leaving a thoughtful comment. It matters more than you might think. And as always, stay curious, stay honest, and stay sharp. This is History's Edge. Thank you for listening.